In section 9.2, we focus on a very specific type of sequence. These are called arithmetic sequences. We are going to look at how do we define or what makes it an arithmetic sequence? How can we tell if something is arithmetic? And then how do we apply our different formulas to create an explicit or recursive rule for those? Okay? You guys looked a little bit at explicit and recursive rules yesterday, correct? They're both good, but for different things. If I said generate the first 5 terms in your list, a recursive rule is easy to do, right? It's easy to use to generate the first 5 terms. If I said find the 100th term, we don't want it recursive. We need an explicit rule. Because with a recursive rule, to find the 100th term, I'd have to know the 99th term. And to find the 99th, I'd have to know the 98th. So you basically have to generate all 100 numbers in your list, even though all you really want is the 100th term. An explicit rule allows you just to put 100 into the formula and get your answer. Okay? So most of the time, if I ask you to write a rule, we're looking for explicit. But I am going to go through a couple recursive ones with you today just to refresh your memory on that part. In an arithmetic sequence, the difference between any 2 consecutive terms is always the same number. The difference between any 2 consecutive terms is always the same. So we can build an arithmetic sequence by adding that same number over and over and over again to generate the list of numbers. An arithmetic sequence is a sequence where the difference between consecutive terms is constant. We call that the common difference. We use a D for that in our formula for difference, common difference. An arithmetic sequence with a starting value of A and a common difference of D looks like this. And I'm going to break it apart here so it's a little more obvious. In a list of numbers, the N that we talk about represents the position the number's in. So first term, second term, third term, fourth term, fifth term, etc. The actual number in that list is your A sub n. Okay? That's the actual number that you see in the list. So they're telling me that my sequence is going to start with an A. To get the next number, I have to add D to it. That common difference. To get the next number, I have to add another D. To get the next number, I have to add another D. And I can keep doing that. Each time I add D, I get the next term in my list. Now I want you to pay attention to the N value and how many D's got added. When N is 2, we only added 1 D. When N is 3, we added 2. When N is 4, we added 3. When N is 5, we'd have to add 4. Because to go from my first term, 1, 2, 3, 4, I had to add 4 D's to get to my 5th number. It's always going to be off by 1 because we didn't have to add a D to get our first number. We already had it. All right? So we're always off by 1. That's why in your explicit rule, one sec. All right. In our explicit rule, we have n minus 1 of our D's getting added in. Okay? Now, there are 2 forms for our explicit rule. I tend to use the first one because it looks a little bit more like the geometric ones that we're going to learn about in a few days. And then you kind of see the same kind of pattern happening. But I'm okay with you using either one. The first one says we start with some number, the first number in our list. We are going to add our common difference. But remember we said we have to add it 1 fewer times? Because we don't have to add it to get the first number. We already have that. So if I want the 10th number, I'm only really adding D 9 times. The second version of this says, let's go back. Instead of starting with the first number and then the second, third, etc., let's go back one space. We call that a sub 0, or the 0th term. It's kind of like saying, if I'm going to add this common difference every time, where would this sequence really have gotten started? So if I add a d to go this way in my list, I can subtract a d to go back and find what that would have started with. Then I can add 1d to get the first term, and add 2d's to get the second term, and add 3d's to get the third term. So by working backwards to the 0th term, we can back this off. Instead of needing an n minus 1, we just need n. Even if we start with this first version, we're going to simplify it down, and it'll look like that one when we combine like terms. But again, I usually start with the first term because it's going to help us with the variety of questions having that basic pattern. Okay? The other format that you sometimes see a sequence formula written in is recursive. This is the one where we have to always generate the number in front of it. So to get the 5th term, we have to know the 4th. There has to be 2 parts to it. Most students forget this first piece. But if I'm going to generate my sequence by doing something to the previous term, there has to be a starting number. If there is no previous term, I can't generate the list. So if I gave you a statement like a sub n equals a sub n minus 1 plus 5, great. It's arithmetic. I'm adding 5 each time, but there's nothing to add 5 to. So I'd have to give you a starting number. Okay? So you do need both parts when you write it recursively. Yesterday we mentioned this being the previous term. So if I'm finding the nth term, the n minus 1th term is the one right in front of it. So if I wanted the 10th number, I'd be adding 5 to the 9th number. Okay? The other thing that we have to talk about is figuring out that common difference. If I generated, I'll just give you an example. Let's say my list was 5, 7, 9, 11, 13, etc. What am I doing? I'm adding 2. So I created an arithmetic sequence. My common difference is 2. Sometimes it's obvious. You can just look at the numbers and know what it is. If it's not as obvious, or if you have to verify it, your d value is always going to be a term minus the one that was right in front of it. For example, the 2nd minus the 1st, or the 4th minus the 3rd. So if I did that with this example, I'd have 7 minus 5. My common difference is 2. All right. I am going to pause the recording. I want you on your green formula sheet. We're going to be filling in the first 3 boxes. Okay? In that first box, you are just defining what makes something an arithmetic sequence. And we said it has to have what? A common difference. There has to be a common difference. It might be helpful for you to write this down in that definition, that there's a common difference. And we find it by taking a term minus the one before it. Okay? So I'm going to pause the recording. Go ahead and put that down. And then also, we want to write down all these formulas in their appropriate box. All right. We're going to start out looking, first of all, just, is it arithmetic? If it's arithmetic, we have to have a common difference. So let's check on this one. To find your common difference, remember you are taking any term minus the one in front of it. So like a 6 minus 3, or 9 minus 6, or 12 minus 9, or 15 minus 12. If I give you a list of numbers, and you're asked to prove if it's arithmetic, you'd want to show me all of those. Show me that the pattern is consistently adding what? We're adding 3. So my common difference is 3. I now know my D value is. And I'm going to actually have us create our explicit and recursive rule for this. All right, so it is arithmetic. And because of that, we can follow those arithmetic patterns. For our explicit rule, we said a sub n equals the first term plus n minus 1 times d. Well, what's our first term? 3. And what's our d value? 3. All right. It's not usually the same number, but in this case, it worked out that it was. Simplifying that, we would want to distribute this 3. So we get 3n minus 3. If we add that to the initial 3, it simplifies to what? Just 3n. Okay, that is an explicit rule. Now, check it. When n is 1, we get 3. That's our first term, right? When n is 2, 2 times 3 is 6. When n is 3, 3 times 3 gets us 9. So it is working to generate our list. For the recursive rule, remember we said there had to be 2 parts. We have to state the first term, which in this case is 3. And then we have to say the nth term is always found by taking the term right in front of it, the previous term, so a sub n minus 1, and we're adding to it 3 each time. Okay? Is the next one arithmetic? If it is, there has to be a common difference, right? So 4 minus 1, 9 minus 4, 16 minus 9, 25 minus 16 should get me the same answer every time. Does it? No. 4 minus 1 is 3, 9 minus 4 is 5. Already we don't match. Not arithmetic. Now, that doesn't mean we can't write a recursive rule for it or an explicit rule. It just means it's not going to follow those patterns we wrote down for arithmetic sequences. Anybody know what the pattern is on this one? It's the perfect squares, right? So when n is 1, 1 squared is 1. When n is 2, 2 squared is 4. 3 squared is 9. 4 squared is 16, right? We're just taking the position it's in and squaring it. So that would be an explicit rule. I could find the 500th term by just taking 500 squared. I don't have to generate all the numbers in front of it. So it's not based on a previous number like this. It's just based on n. Okay? So this would be a way we could write an explicit rule for that sequence. But it doesn't fit the arithmetic pattern. All right. Next one asks us to find the 100th term. They are telling me it's arithmetic. Now that's helpful because how many numbers did they give me in the list? Only 2. With only 2 numbers, there's no way to prove it's arithmetic. I can't prove there's a common difference if there's only 2 numbers. But they have told us it's arithmetic. My common difference, remember, is any term minus the one in front of it. So in this case, my common difference is 5. And we know our first term. Those are the 2 things we have to figure out in order to write our rule. If we are going to write an explicit rule, our formula says the nth term is the first term plus n minus 1 of our common differences. Let's plug in what we know. Our first term is 6. Our common difference is 5. could we write a rule for that? Could we simplify that a little bit? Yeah? Distributing, we get 5n minus 5. Plus that 6 gives us what? Okay. So 5n plus 1 or 1 plus 5n, it doesn't matter. That is how we find the nth term. In this case, they asked us to find the 100th term. That just means our n value is 100. So plug 100 in for n. Our 100th term would be 501. Okay? Now, they didn't ask me, and to find the 100th term, it would not be very useful, but I could write a recursive rule. What's my first term? 6. The nth term, I'm going to take the previous number and do what to it? What am I adding every time? I'm adding 5. That would be the recursive rule for that. Okay? So again, if they just wanted a third, fourth, fifth term of my sequence, that would be convenient. It's not very convenient to find the 100th term with that one. All right. What are the second and third terms of the arithmetic sequence? 100, and then we have 2 unknown terms, and then an 82. So I know the first term, I'm missing the second and the third, and I know the fourth. Okay? We can use our explicit rule to work backwards. I cannot identify D when I'm missing terms in between. D has to be consecutive numbers being subtracted. Okay? I don't have consecutive numbers, but I have enough that I can figure out D. I know my first term is 100. And the other thing that I know is that my fourth term is 82. Well, if the fourth term is 82, that means if I put a 4 in for n, if I replace n with a 4, I should get 82 for my answer. Let's say that again. If the fourth term is 82, then if I put a 4 in for n, I should get 82 for an answer. Simplifying, we have 82 equals 100 plus 3d. We can solve for d. What do I get when I do 82 minus 100? Okay, negative 18 equals 3d, which means d has to be negative 6. Now, a negative value for d means what? It's going down. We're subtracting 6, right? Or we're adding a negative 6. So, are my numbers going down? Yes. I went from 100, I skipped a couple, and I got to 82. So my numbers have to be going down. So to find my second term, can I do 100 minus 6? Which gets me 94. To find my third term, can I do 94 minus another 6? And I get 88. And if I subtracted 6 again, would I get to my fourth term of 82? All right. I'm going to pause the recording. I want you guys to try the next one. All right. Starting out again with our formula. You'll notice I've been writing this down in every question, right? That's how I start to learn them, writing them down a lot. I know my first term is 80. I don't know my common difference, but I know that my fourth term is 125. So again, putting a 4 in for n should get me 125. Subtracting the 80, we get 45, and we get 15 for a common difference. Okay? So we're adding 15 every time. So my second term would be 80 plus 15. My third term takes my second term, adds another 15 to it, and I get 110. And double checking, add another 15, I get to 125, which is where I was supposed to land. All right, questions so far? All right. You've heard the term mean, right? Mean, median, mode, statistics, mean, average. An arithmetic mean, or average, of two numbers. We simply add them together and divide by 2. In an arithmetic sequence, if I picture 3 consecutive terms, the middle one is just the average of the 2 on either side of it. So in a list of numbers, if my first one is x, I'm missing another number, and my next number is y in my list. Okay? And it doesn't have to be the first. There could be numbers in front here or on the end there. But if I take a sequence that's arithmetic and pick any 3 consecutive numbers, the middle one is the arithmetic mean or average of the other 2. So in this example, it says, what is the missing term for the arithmetic sequence? We have 3 consecutive numbers. I'm looking for the middle one. I simply have to average the other 2 terms. What do we end up with? 37. Now, I can check that, right? If I say it's 15, 37, 59, what did I add to go from 15 to 37? I added 22. Can I add another 22 and get to 59? All right. Go ahead and do the next one. My 10th term should be the average of the 9th and the 11th. So 132 plus 98, then divide it all by 2, we get 115. Questions on that? It says the number of seats in the first 13 rows in a section of an arena form an arithmetic sequence. Rows 1 and 2 are shown in the diagram below. How many seats are in row 13? So we are given that in row 1 there's 14 seats and in row 2 there's 16. We are going to call the row, that'll be our term number. So the first row would be considered our first term. We have 14 in that row. My second row, or the second term in my sequence, is 16. And they're asking me to figure out the 13th. Okay? They've told us it creates an arithmetic sequence. So there's a common difference. What is it? All right. So if I know my common difference is 2, I should be able to figure it out, right? Do I have to know how many are in all the rows in between? No. So I'm going to go ahead and use my explicit rule. They did not ask me to come up with a formula or rule for this. They just want to know how many are in the 13th row. So they want the 13th term. So I'm going to go right to saying, I want the 13th number. My first term is what? 14. I have to add some common differences. What is my common difference? A 2. Now, the question is, how many of those do I have to add? If I want the 13th number, and I'm starting with the first number, I need 13 minus 1, right? N minus 1 of my common differences. So I need to add D 12 times. What's 12 times 2? 14 plus 24 is 38. So there's 38 seats in the 13th row. Okay? Now, I want you to notice before we move to the next question. If you look at your subscripts, starting with the first term and trying to get to the nth term, we had n minus 1 of our common differences, correct? I could shift that. Maybe I don't know the first term. Maybe I know the 5th term, and I want to get to the 13th. Well, if I knew the 5th term, and I still wanted to get to the 13th, then I'd put 13 minus 5 in there. Does that make sense? I'm just shifting where I'm starting from. That's how we're going to have to do this last question. It says find an explicit rule for the nth term of an arithmetic sequence given that a sub 10, or the 10th term, is 17, and a sub 14, the 14th term, is 34. So in my list, I have some numbers, then I have a 17. I don't know the 11th, the 12th, or the 13th, but then the 14th term is 34. Yes? We want a rule for this. We don't have consecutive terms, so we can't use just subtraction to figure out D. But we know enough that we can find D, and then we can work back and find our first term. Instead of starting with the first term, I'm going to start with the 10th term, because that's really the first number that I know. If I'm trying to get up to the 14th term, how many common differences do I need to put in there? Subtract your subscripts. Instead of n minus 1, we're going to have 14 minus 10. 14 minus 10 is 4. Yes? To get from here to here, 1, 2, 3, 4. I have to add 4 D's. Make sense? All right, let's substitute in the things we know. Our 10th term is 17. We said 14 minus 10 is 4. And my 14th term here is 34. Subtracting 17 gets us 17. This one's going to be a little messier. We're going to get a decimal. That's okay. What's 17 divided by 4? Okay. That's one of the two things that I have to know to write my explicit rule. The other one is a sub 1. So we're going to go back. A sub n equals first term plus n minus 1 times d. I am trying to find a sub 1. I figured out that d is 4.25. And I can use, for my answer over here, I can use either of the terms they gave me. I can use the 10th or the 14th. It doesn't matter. I'm going to pick the 10th one. It's a little smaller. Okay? So if I put the 10th term in here, then I would have 10 minus 1 here. Does that make sense? My 10th term was a 17. 10 minus 1 is 9. Can I figure out 9 times 4.25 and subtract it to the other side? All right. If I do that, I end up with negative 21.25. That is my first term. And now I have the two things that I need to write my rule. All right, go ahead and figure out the rule. Distributing should get us those pieces. 4.25n minus 4.25. And then combining like terms, I can put those two together as negative 25.5 plus 4.25n. Okay? Questions? All right. Your assignment for section 9.2 is listed here.